Hi, this is Mr. Blanche, and I wanted to take advantage of the solar eclipse that we just had to do a little video lesson. So, um, a solar eclipse happens when the light from the sun is blocked by the moon passing in front of it. And the geometry for this is pretty unique in that the sun is 400 times larger than the moon, but the moon is 400 times closer to the earth than the sun. So they become equal sized objects in the sky to us. And the question that you would ask is, what would this alignment look like? Well, so here's a not to scale drawing of the Earth, Sun, and Moon system when an eclipse is possible. And of course, when you see that, you would say, well, since the moon goes through a cycle where it's in front of the sun every month, how come an eclipse doesn't happen every month? Well, this is because the moon's orbit is slightly inclined to the plane of the Earth and Sun's orbit, and this inclination is about 5 degrees, which doesn't seem like a lot, but it allows only the eclipse to happen when the moon is on the descending or ascending nodes, in other words, lined up directly with the sun and at the new moon. So the eclipses are fairly infrequent. They happen on a very unique cycle that takes 318 years. The good news is that next month or next year there will be an eclipse that will be available through most of the eastern United States, about halfway between the east coast and the Mississippi. And this will happen in about the same time next year, so I believe late February. The images that I have on the screen are from NASA's Exploratorium, and what you're seeing right now is that the surface of the sun is being occluded by the moon, which is the dark shadow, and they've just zoomed in and focusing on a sunspot, and that sunspot may be about the same size as the Earth would be if it was placed on the surface of the moon. In this image, they're using a different type of filter on the telescope, and you can see the granulations on the surface of the moon, or the surface of the sun. And these granulations are sort of the small surface features that make up the sun, and most of these are manipulated by the magnetic fields that are present on the sun. This filter is, I believe, is in the hydrogen alpha band, so it's showing you the light that's emitted by hydrogen alpha, hot hydrogen, as it emits as the electrons drop back down to the lower energy state and emit photons. And what you'll see if you watch some of this video is you'll see the moon slowly moving across the sun. Now, if you watch the moon in the sky at night compared to another object, you'll see that it actually moves amongst the star fields. And this is because the moon has a rate going around the Earth that is not quite equal to the rate of the stars or the sun. So the moon will appear each day about an hour different location, and I would like for you to try to observe that during the course of this class. The moon will first be visible in a few days as a crescent on the western horizon. It'll move till it'll be due south at sunset. It'll move till it'll be due east at sunset, and that would be the full moon. And then it will move till it is south at sunrise, and then it'll continue to move until it is due east at sunrise, which is the condition that exists today for this eclipse. So the moon and the sun are in the same part of the sky. The moon is on the ascending or descending node, and that node is pointed directly from the Earth to the sun. So all these things are aligning, and the moon is casting its shadow on the Earth. And when we reach the part of totality, which I'm not going to record, I'm going to make you watch that, you're going to be able to see part of the sun that you don't normally see. And that part of the sun that you don't normally see is the sun's atmosphere. And the reason we don't normally see the sun's atmosphere is because it's not as bright as the sun. So the eclipse offers a rare chance for us to block the light of the sun so that we can see the dimmer solar atmosphere. It also provided, an eclipse provided the uh, evidence or the data that allowed Einstein's theory of relativity to be worked out. Einstein's theory of relativity states that gravity distorts space-time, and this distortion of space-time will affect light. So stars that are near the sun, the light will be bent by the gravitational field of the sun. The only way to prove this is to take images of stars during a solar eclipse and then compare them to images of the same stars when the sun is not in the area, and to see if the light is deflected by a very small amount. And this it took a while after Einstein's theory was put out for this to be accomplished, and it finally was, and with very dramatic presentation, the people collecting the evidence stood underneath of the portrait of Sir Isaac Newton and stated that Einstein's theory was correct, meaning that Newton's theory, or Newton's mechanics for gravitational force, were not quite right. The crazy thing is that we still use a lot of Newtonian physics for ballistics, rocket flight, space travel, and things like that. So here we're approaching the point where the moon has almost covered half of the sun, and it's going to continue to move very slowly across the screen until it blocks out all of the sun. And if you see the camera shaking in these videos, that the shaking of the image in the videos is usually caused by the wind, if somebody's not touching it. But the wind's probably blowing, and the telescope system will shake a little bit. One of the cool things about seeing eclipses are the effects of the sun on the shadows. So during this phase of the eclipse, when the moon is only partially covering the sun, very cool things happen with the shadows. And I'm not going to show you images of these because I'd like you to go look them up. But if you look up eclipse shadows on the web, you'll find all of these neat images. Every shadow cast by the sun during an eclipse has the eclipse image in it. And I saw this effect in 1997. I was in North Carolina at school at Wake Forest University, and we had a partial eclipse. And while everybody was looking at the sun using different viewers of different types, I happened to turn around and look away, and there the sun was going through the leaves of the trees, and everywhere the sun hit the ground was a shadow of the eclipse. And it was the most phenomenal thing, and I tried to get everybody's attention, but it took a long time before I finally did. And there were all these little eclipses gently swaying back and forth across the big patio that we were on as the sun was slowly blocked out by the moon. So it's not safe to look at an eclipse directly, because during an eclipse the sun's light is dimmed, but the sun's infrared energy is not, and your eye cannot detect infrared energy. However, infrared energy will damage your eyes. So during an eclipse you are able to look at the sun because it's not so bright that it would blind you, but the infrared energy is still the same brightness and it will damage your eyes. So do not ever look at an eclipse directly. There's many devices available for it, solar eclipse viewers. Uh, when I was a kid, there was an eclipse in the area I grew up in, and we made shoe boxes with a pinhole in one side, and the pinhole would project the shadow of the eclipse on the other side of the shoebox, and they were great for viewing. But there's many things to view with. Most recently, the most dramatic eclipse I've seen was a partial solar eclipse at sunrise, and I was able to set up a pair of big binoculars with filters, and the filters allowed me to see the sun. Now here's what you would see when the image of when the moon is fully blocking the sun, and this is the corona. We'll talk about more about this later. And also during the totality phase, the moon's shadow would appear on the surface of the earth. So this is an image from space. And finally totality happens, the moon gets blocked, the sun gets blocked out, and then eventually the moon moves off of the surface of the sun, and the sun starts to reappear. And the whole environment seems to be changed by this event, because the first one I experienced when I was old enough to know what was going on, as the sky got dark and the stars started to be visible, all the birds quieted down, and all the animals, appeared like it was nighttime. And it was very neat effect, and it made quite an impact on me. So I've been able to see, I believe, almost 6 or 7 eclipses, either total or partial eclipse. I think I've seen 2 total eclipses. One was when I was very young, so I can't remember whether it was total or not. But next year you'll have the opportunity to see an eclipse, and you should go out of your way to make sure that you're able to see that. They happen on a very wide span cycle. They usually happen in pairs, so the pair to this eclipse that occurred just the other day will be next year, and then there won't be another one for a few years, and there won't be another one for several years in the United States. So this might be your last chance to see it. But I hope you can imagine that this is quite a spectacle, but at the same time it's quite an opportunity for scientists to learn much about the sun, in that they can view the coronosphere, which is the atmosphere of the sun, without the influence of the sun. And that image that I showed of the coronosphere, the totality of the sun, that was one of my favorite images. It was taken in 2008, but it shows all the filaments and the banding and the energy flow that happens in the chronosphere. So I hope you had a chance to see this. If not, watch the video. If you don't want to hear what I have to say, just turn the sound down. But it was quite a spectacular event, and it's great now that all these eclipses are available worldwide.